Hello, my name is Connor Devoto, and this is a short presentation for Group 10's Data Mining and Predictive Analytics final project. For our project, we were tasked with exploring a minimum of 3 machine learning techniques to accurately predict results from a real-world dataset. We have covered several different machine learning techniques in class, and our team was excited to put the skills that we have learned in class to the test with a real-world dataset and some unguided analytics. Our team did some research on available datasets for machine learning and found the Vino Verde dataset on Kaggle. The original dataset has 1,597 instances, each with 11 attributes that relate to wine. Each wine is also scored on a scale from 1 to 10, 1 being the lowest quality and 10 being the highest quality. I'll talk through the dataset in more detail shortly, but I want to ensure that our project goal is clearly communicated in context to our dataset selection. The goal of our project was to build multiple machine learning models that can accurately predict a wine score based on its 11 attributes with a minimum of 60% accuracy. Now, let's discuss our dataset in more detail. The Vino Verde wine set contains over 1,500 wines, along with their attributes and scores. In this case, the attributes are considered the inputs for the model, and the wine quality score will be the output, or what we are working to predict. The 11 attributes include fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH, sulfates, and alcohol. Our report includes a detailed description for each attribute and tells what each attribute means and how it can influence the taste of a wine. To ensure that we had a good understanding of our dataset, our team performed an analysis of each of the attributes using a histogram from Seaborn. In general, most of the attributes are normally distributed or slightly left skewed. For some attributes like residual sugar and chlorides, there were some outliers with abnormally high values, but our team did not exclude or manipulate these values. The wine quality is also considered normally distributed, with values heavily concentrated in the 5 to 7 score range. From a data quality perspective, every wine had a value for all 11 attributes and score, so there were no instances of null or missing values for any of these attributes. Now that we have provided a brief overview of the data set we have selected for our projects, I would like to briefly introduce the machine learning methods that we performed. The project requirement was that our team explore a minimum of 3 different machine learning techniques. However, to ensure that we did a comprehensive analysis on the different methods that we have discussed in class, our team evaluated 6 different methods. We performed a logistics regression model, support vector machine learning model, decision tree model, random forest model, 6NN classifier model, and a sequential model. We've included a high-level overview of the process for each of these models in the chart displayed on the slide. Now that I have walked through our project overview and goals, dataset characteristics, and machine learning methods that we have evaluated, I'd like to pass it on to the rest of my team to discuss our results. Thank you.
So this is our modeling approach. First, we import all the necessary models, and then we import the dataset in CSV format. We split the dataset into a training and testing matrix with 80%, 20% side distributions and a random state of 0. For each model, we will first fit the model with the trained data and report the accuracy, and then we validate the model with the test data. We plot the confusion matrix and print the report for analysis, and then we apply the 5-fold cross-validations and report the average accuracy. We compare the accuracy of each model. The results we will present in the next slides. We'll summarize our initial results. Based on the analysis, 5 out of 6 models achieved the success criteria of 60% accuracy for the test scores. And for the five-fold cross-validation scores, most models also achieve higher score than 60%. We can see that the random forest model is the best performer in all criteria. It has a 100% training score accuracy, 73% test score accuracy, and the average 5-4 CV score is 69%. On the other hand, the sequential model is the worst performer with only 49 to 57% scores. Once the initial results satisfy our goal of a minimum of 60% accuracy for the test validations, we believe that we can further improve the accuracy. We decided to group the wine score into three categories as shown in this table. The first category is a low quality with a score of 0, composed of wine score from 1 to 4. The second is a medium quality, a score of 1 with a wine score from 5 and 6. And then the last group is a high quality with a score of 2. And we can see that the majority of data points, more than 82%, concentrated in the medium quality group. Using the new formatted output, we rerun our models and achieve significantly improved results. Now all models can achieve more than 80% test accuracies, as you can see from this table. And again, the random forest model appears to be the best performers with a 100% training score, 89% testing score, and the average five-fold cross-validation score is 87%. We believe that grouping the wine score into three categories in this way will be beneficial because there is not a clear difference between a closed wine score, say between 5 and 6 or 7 and 8. In the future, to further improve our model, we will explore different machine learning methods like functional API. And in addition, we recommend that the dataset should be more evenly distributed, meaning that the number of data points in each wine score group should be relatively the same.
In conclusion, the team was able to achieve the target outcome with 6 models of wine, achieving greater than 60% predictive accuracy. Out of all the models that were used in this project, the random forest model is the one that performed with the highest level of accuracy for predicting wine scores. For this reason, we recommend using this method when analyzing potential wine scores based on the set of 11 attributes that were given. The team believes that this dataset could be further improved by either adding more range of scores, adding more attributes than the 11 provided, or setting a more distinct boundary for the wine scores, which could be moving from 10 to 5 scores.